This lesson will focus on branch assignment. I will be showing you branch assignment using both traces only and picks only. At this point you can see that on this record in front of you we have a shot record with 6 receiver lines, and it looks pretty completely picked. Let's go around the survey here, and you can see I have pretty consistently picked this survey. Not too many mispicks, at least it seems. There's 1 or 2 there. But anyway, we're going to use these picks to do branch assignment. Under delay time, as you can see, there's 2 types. So first, let's use branch assignment using picks. Now I was already doing some branch assignment before, so I'm going to remove these so we can start afresh. And I'm going to click here, and here's my picks centered on this CMP here. I'm going to apply linear move out, because linear move out makes things a little easier to see what's going on. And at this point you can see that we actually have 3 refractors if you look closely. We have 1 refractor here. You can see like a trend in the picks here, and it's ranging about 55 to 5,600 feet per second. We also have another one over here, and he's 5,900 to about 5,900 feet per second. And then there's another one here, it's even faster, which is about 6,800 feet per second. So I'm going to focus in on this first one. And as I do this, as I'm drawing this, I'm trying to go through the middle of my picks here on the second refractor. And I'm doing 4 things. I'm looking at a minimum distance, which are the minimum distance and the maximum distance, or the horizontal extent of this pink little box. And up above, you'll see that I have as my axis up here in feet. And the other thing I was doing, let me do this again, you'll see that I'm actually setting a velocity and a delay time. So the velocity is the dip of this line. Now I have a velocity applied to this to this particular gather at this point of 5,914 feet per second. You can see that up here. Remember this here? So at that time I was doing about 5,914, and that happens to be the exact slope of this line. But I'm going to do it backwards here, and I'm going to project back to 0 offset. And 0 offset, if you look at that scale, that zero distance up above is right about there, and you can see my delay time that the program's computing is about 35. If I go up above here, it's more like 30, and here it's about 40. As you can see by the axis on the left here, it's half of what that axis is. A delay time is a half of an intercept time. So when I'm going to here, if it says 36, then I must be intercepting 0 at 72. As you can see, I am slightly lower than, or slightly beneath 70 there. On this axis here, if I go up to about 40, I get a delay time of 20. So in other words, when I project this, so when I'm doing this line here, setting this line, I'm setting velocity, delay time, minimum distance, and maximum distance. I'm going to drop it there. Doesn't matter whether if we set it from left to right or right to left. And now you can see the location of my branch assignment. Now I'm going to go over here and do it again. Now the program has interpolated this well, in this case it's a constant. But I'm going to go down here and go after this particular leg. Over here, I'm going to go, let me apply a different linear move out. You can see the velocities changing here, and now the velocity is more like 6,200. Over here, like that, and over here you can see it's a very small little segment. Let's look over here. Let's apply linear move out. Doesn't matter. The linear move out is just to help us see better. It doesn't change really the velocity. As long as we go through the middle of the picks, the velocity's got to be about the same. And let me go over here and do the same. Okay, so maybe one more in here, just because it looks like I have a hole in my map there. Okay, so here I have my minimum distances, my maximum offsets, or distances that I've been setting, and you can now also display the velocities, and you can see the velocities range from about 5,950 to 6,250, or about 1,000 maybe about 300 feet per second range, or about 100 meters per second. And down here I'll plot the delay times. And you can see the delay times range from a 34 to a depth. The deepest part is about 52 milliseconds, and the shallowest is about 34 milliseconds. So let's save this. We're going to apply the changes. The program's going to ask if we want to interpolate these. We say, sure, let's interpolate them. So what this means is it's going to interpolate these to the database. So these velocities and delay times will actually be applied, interpolated, and then to each of the shot and receiver locations in our database. So let's do that. And we're not going to use this for cleaning up any missed picks, so we'll just say no. And we're not going to do the delay time analysis. We'll say not now. Okay, so that's how we set branch assignment using picks. Now at this point, we can actually observe the effects of this branch assignment on our data. So what we can do is we can, under here defaults, if you prepare options for delay time analysis, this is a convenient set of operations on here. What it's done is it's set three things. It's saying, let's apply the delay times, which are the ones we've interpolated from our branch assignment. It's applying a filter. It's also picking the event closest to the 0 time. I'm going to turn off that one because I don't want it to repick any. And so a perfect solution would be 0. Now let's look around the survey and let's just use this to help us see how well we're doing. You can see a few mispicks here and there, probably not worth cleaning up. Here there's some uncertainty, frankly visually I don't know where I really want to be. It looks like there's an event that we want here with some kind of interference pattern. So here's some mispicks. But as you can see, it's done a pretty good job isolating the refractor, and again a perfect solution would be perfectly flat. And here I have some places where it's not quite perfectly flat, but we're at a very crude part of our analysis at this point, so I'm not too worried about it. Okay, so now the other type I wanted to show you was branch assignment using traces. So let's go on up under here again, and now let's use traces. Now I'm going to remove all branch assignment, and I'm just going to start from scratch. And now we're looking at these pink dots. These pink dots are where we have our sparse CMP traces from when we built our geometry. If you recall, we actually requested the program choose the option, and in my case I think I used every 3,000 or every 2,000 feet. So if I click here, you can see the program brings up traces immediately. Let me unapply the linear move out and apply the linear move out. Here I am over here. So let's zoom in on our traces, and I'll set the axis to be -200 to 300, and let's look again. So instead of the picks, we're looking at the traces associated with those picks. So I'm going to set one here, not there. Let's do one here. So I'm going to go after that second refractor like I did before. As you can see, we have a shallow or a slow velocity. Let me redo that whole thing here. 5,500 or so, 54. About close to 6,000 feet per second, and another one that's closer to 6,700 or 6,800 feet per second. So again, I'm going to go after this refractor here in the middle, right here, set it here, and then set it down here. Again, we have our offset ranges, changes in our offset ranges here. We can look at the velocity range that I've been specifying, which ranges from 5,900 to about 6,100, or about 200 feet per second range, or less than 100 meters per second range, which is a little tighter than we did on our picks. But now we're looking at the traces, and I actually prefer looking at the traces most of the time for setting my branch assignment. And then here, let's look at the delay times. And the delay times, as you can see, are tighter than before with the picks. We have 35 milliseconds to about 44 milliseconds. So again, things are tighter. I'm going to apply the changes and say, do you want to interpolate? Say yes. This will wipe out what we just did on the pick, the branch assignment using picks. But we're in a demo mode here, so this is not normally what you would do. You wouldn't normally do the pick branch assignment and then turn around and do the trace refractor assignment or branch assignment, you would choose one or the other. Like I said, I personally prefer the traces. But anyway, so I don't want to kill any picks using this. So, and I don't want to go into an analysis. So again, if I click around, I can apply that solution, and now I'm a perfect solution where I'm applying my refractor velocities, and my delay times would be 0. This one here looks a little strange. This might be a geometry problem. Here's the vectors up here. I'm not going to try to change them. I'm not quite sure what's going on with that particular shot. This one looks pretty clean. This one here just looks like some mispicking, or at least a wrong choice of events. The refractor I want is this guy here by the analysis, so I'm gonna, if there's any question before, the picks that were up here do not belong to the refractor I'm picking, so I'm gonna readjust those. Not bad, not bad, not bad. And let's just clean this guy up. All right, so anyway, that's showing you how to do refractor assignment using picks and using traces. 2 different ways, you choose. Thank you very much.